Let's delve into the concept of central tendency, which involves summarizing data. Specifically, we will learn about the mean, also known as the average, the median, and the mode. Let's explore how to condense data into a single representative value using measures of central tendency. Imagine we're assessing 10 food reviews for a restaurant, each rated on a scale of 1 to 3, with 3 being the highest honor, indicative of exceptional quality. These scores can be challenging to interpret individually, so we aim to condense them into a single meaningful value. Visually, we represent this data with a bar chart. Each bar represents a customer, and the bar height represents the ratings or review. To find the representative number, we calculate the mean using the formula, where mu is the average, and it's the sum of all values divided by the total number of data points or customers, represented by the letter n. Towards the right side, we represent this using the sigma, which indicates a summation. In our example, adding the values gives a total of 18, which, divided by the 10 data points, yields an average value of 1.8. In the bar chart, we have included 10 new purple bars with a height of the average. Simply put, the average indicates the score that every customer would provide if they all gave the same rating. However, averages can be sensitive to outliers, as demonstrated when one customer drastically changes their score from 1 to 30, raising the average to 4.7. This sensitivity is visualized in the chart, highlighting the impact of outliers. Notice that the average value is higher than all the scores with the exception of 1. The gap between the two averages is significant. The median, another measure of central tendency, indicates the middle value where half the data points are above and half are below. To find the median, we sort our data ascending or descending. If we have an even number of data points, we find the middle values, which in our case are the 1 and 2. The median is the average of these middle values, which is 1.5. The median, as opposed to the mean, is less sensitive to outliers. In this example, having a value of 30 on one of the customer's ratings does not affect the median value. If we were to drop the last data point such that we have an odd number of data points, the median would be the middle value, which is a 1. The idea of median can be extended to splitting the data into 4 parts known as quartiles, 10 parts known as deciles, or 100 parts known as percentiles. Lastly, the mode identifies the most common rating. We start by creating a histogram with 5 1s. We have 2 2s and 3 3s. In our case, the mode is 1, occurring 5 times, making it 50% of the dataset. Datasets can be unimodal if they have one mode, bimodal if there are 2 modes like the graph on the right, multimodal if there is more than 2 modes, or lack a mode altogether if the count of all values is the same. Summarizing our data, we have a mean of 1.8, a median of 1.5, and a mode of 1. These values provide insights into the central tendencies of our dataset. Comparing these with another restaurant's reviews, where the mean, median, and mode are higher, with values of 2.4, 2.5, and 3 respectively, suggests a more favorable experience on the restaurant on the right. It's worth noting that in symmetrical distributions like the normal or Gaussian distribution, the mean, median, and mode align.